Cargo Math. Hello and welcome to the beginning of our Algebra 1 Semester 2 study guide video. We're going to do questions 1 through 10 here. I will show you the answers and go over kind of the explanation for each one. So let's get started here. So in our first question, we're asking what type of function is this function here, which is f of x equals 2x plus 5. So we have exponential, linear, quadratic, or none of the above. So as a reminder, I know the type of function that this is based upon its degree, and the degree has to do with the exponents of the variables. And so because it only has one variable, and that variable is to the power of 1, we know that this is just a linear function. Another way that I could remember or realize is because this equation should look familiar. It should look just like y equals mx plus b, because f of x and y mean the same thing. This is just function notation, and this is slope-intercept form. And we know that slope-intercept form is a linear equation, so that is another reason why it is linear. Okay, so the next question, we're looking at the area of a rectangle. So we know that the area of the rectangle is 6x squared plus 8x plus 2, and that one side of that rectangle is 3x plus 1. Our job is to find the width. All right, so here I drew an image. Here's my rectangle. The area is this formula inside. One of the sides is 3x plus 1, and the other side we don't know. So to find the area of a rectangle, we need to do length times width. So that means I'm looking for a product of two binomials that would multiply to equal this trinomial. So there's a couple different ways that we can do this. One of the ways is kind of guessing and checking all of these answers times 3x plus 1 and seeing which one equals the 6x squared plus 8x plus 2. The other thing I could do is I could write an equivalent expression here by dividing all of this by 2, and I would get 3x squared plus 4x plus 1. That is going to give me my 2 in front of whatever I factor out here. And then I could go ahead and factor this. So I'm going to do my a times c. We're going to multiply those together. 3 times 1 is 3. Factor that apart. We're going to just use 3 and 1 to make 4. So now with my grouping method, I would have 3x squared plus 3x plus 1x plus 1. Group those apart, and you're going to get 3x here, x plus 1, and then, whoopsie, this will just be a 1 here, and that's just x plus 1. So then my new factors are going to be 3x plus 1, which is the one that we were looking for. And then it would actually end up being 2 times x plus 1 because of this extra 2 we factored out. And when I multiply that out, I'm going to get 2x plus 2. So the answer, I have wrong on here, is not B, it is D, 2x plus 2. On question number 3, we're going to take a look. We have this equation here in standard form, which is that equation about velocity and height. And it's asking how long does it take the ball to reach its maximum height. So when we're looking for maximum height, we're thinking of a graph, right? So if the ball's thrown like this, the maximum height is y, and the time it takes to get there is x. So I'm looking for the x value of the vertex. So in order to find vertex of standard form, I'm going to use negative b over 2a. So I'm going to do negative 32 over 2 times negative 16. And that ends up being negative 32 over negative 32, which is how I get 1. Now, continuing on the bottom question, it's the same idea, it's the same equation, except we're looking for the maximum height. So remember, our maximum height is y. So I'm going to take my x value, and I'm going to plug it back into my equation, times 1 squared plus 32 times 1 plus 10. That ends up just being negative 16 plus 32 plus 10, and that's how I get 26. Okay, so that's the first 4. On number 5, there's a couple of different ways to do this. The way that we're going to do it is because we're going to look, remember that your parent function starts at 0, 0, right? It's on the y-intercept, it's 0, 0, and it kind of goes like that. So I need to know where the vertex goes in order to know where my new function has moved from the parent function. So we're going to find the vertex, okay, of number 5. So same thing, I'm going to do negative b over 2a, and that becomes negative 2 over 2, which is negative 1. So that means that I transferred 1 to the left. If I then take this x value and I plug it into my equation to find y, I'll do it up here. I would have negative 1 squared plus 2 times negative 1 plus 1. And that becomes 1 plus negative 2 plus 1, which is 0. So my y value is 0, which means that y goes nowhere. Okay, so my new vertex is negative 1, 0, and therefore all that happens is it transforms 1 to the left. Okay. Our next problem is using the quadratic formula, which means I'm going to be using my little song to remind me of my equation. So negative b plus or minus square root b squared minus 4ac all over 2a. And I'm going to go ahead and plug in these numbers here. So my b is 7. 4 times 2 times, oopsies, I forgot to move this over. So over here, I need to subtract 3 from both sides. So my equation is actually x squared plus 7x minus 5. And then at the bottom, I'm going to do 2 times 2. So I'm going to plug this all into a calculator. And what you're going to end up getting is negative 7 plus or minus. It's 49 here. And then 4 times 2 is 8 times negative 5 is negative 40. So 49 minus negative 40 makes 89. And we're going to divide that by 4. So if you plug this into a calculator, you get negative 411 and negative 16. So let me show you that because I know that we were struggling with kind of when to round with our calculator. So this is what I would do, okay? Clear. Okay, so I would actually do my square root first. I would do 89 square root, and then I would do either addition or subtraction. So let's add negative 7. So on my scientific calculator, I'm going to use the 7, and then I'm going to use the positive negative, here it is, to turn it negative. Then divide that by 4, and that's how I get the 0.608, which I would round to 0.61. Okay, then when I'm doing the next one, same thing, 89 square root. Then I'm going to now subtract the negative 7. And I can only do this, oopsie, that doesn't work. Or actually, never mind, because, clear. I can actually go in order, so I can do 7 negative. And then I'm going to subtract 89 square root. And because this is a scientific calculator, it's going to keep that in there. It's going to do it in the right order. And then I'm going to divide by 4. And that's how I get, hold on, I did something wrong. 7 minus 89 square root divided by 4. There we go. So I'm going to get my negative 4.11 rounded. Okay, on number 7, we're looking for the factored form of this expression here. So because they have, they're all even and they have so many variables in them, I'm actually going to find the GCF of all of these. And so I can do that by just looking at my answer choices. I mean, you can look at all of them and say, what do they have in common? But if you're struggling with that, most of your questions on your final will be multiple choice. Use that to your advantage. It's probably 2x squared or it's just 2x. So if I look, they all have 2x squared as factors. So I factored that out first, and then I got the 3x squared minus 8x minus 3. I did 3 times negative 3 to get negative 9, because that's my a times c, to find out with my grouping what my new factors are going to be. And then I found the GCF of each one. And that's how we ended up getting B. Okay, and number 8, we're trying to find the area of square C. I know that the area of square A is 6, so the side length of 6 would be the square root of 6, because the area of a square is side times side, or side squared. So that means that this is the square root of 6, that length right here, okay? For C, same thing. The side length of the area of C, we don't know what number it is, but if I do the square root to find the side length, it's going to be the square root of C. The length times width equals area of a rectangle. The length is the square root of 6, the width of a square root of C, and the area is 5 as given to me in my rectangle. In order to get rid of these radical symbols, I need to square every single term. So square root of 6 squared is 6, square root of C squared is C, and square of the square root of 6 is 6, the square of the square root of C is C, and the square of 5 is 25. Divide both sides by 6, and you get your answer B. All right, on number 9, we have to find the zeros, and there are so many ways to do this. So you could factor, you could use quadratic equation, you could complete the square, you could use guess and check, and there's probably more. I'm going to show you factoring because that's my personal favorite. I think it's the easiest, but whichever one makes the most sense to you, use. Sometimes looking at the equation, you can tell like, ooh, that has a number in front. I don't want to complete the square because I don't want to deal with a not equaling 1. So therefore, I'm going to use one of the other two. Or you could just be a diehard quadratic equation fan or quadratic formula. That's what the formula. So anyways, here I went and factored. I multiplied A and C. I got my terms. I grouped. I found my GCFs. And then I found the zeros, right? So I set each binomial to 0 and I solved. And that's how we got A. All right, and then the very last one is another what type of function is this? So again, we're looking at the degrees of the variables here. So x squared, x to the second power, that is our highest degree, and anything to the power of 2 is quadratic. So linear is 1, quadratic is 2, and then as a reminder, exponential starts to look like y equals 2 to the power of x. That would be an exponential function, things like that, okay? Well, good luck and let me know in class if you need any help.